Hi, I'm Jeremy Simon with 3D Universe, and welcome to today's episode of 3D Universe Untethered. This is our second episode, and today we're going to be talking about digital fabrication in a remote learning environment. We had a little bit of a technical difficulty with this being only our second session of this series, and actually lost the recording in the first few minutes, so I'm re-recording this introduction, and then the original recording is going to start up in just a couple of minutes as the speakers get started with their discussion. So we go through the introductions here of who we have on the panel today. We've got Jeff Solin. Jeff is a computer science and making teacher at Lane Tech High School and winner of the 2018 NCWIT National Educator Award. He co-founded CSTA Chicago and helped bring the Exploring CS curriculum to Chicago Public Schools. Jeff designed and built Lane's LT Maker Lab, a 4,000 square foot makerspace, as part of his work bringing Maker Ed into schools. Curriculum, professional development, and project collaborations include the James Dyson Foundation, Argonne National Labs, SAIC, University of Chicago, Indiana University, the Chicago Cubs, and the National Science Foundation. Jeff is also an organizing leader for the Illinois PPE Network, and designed the Solin face shield, a flat pack, single material face shield that's being mass produced and donated to those that need it. We also have Kevin Smith with us today. Kevin is the Vice President and Creative Director at BitSpace, which is an organization that's focused on empowering children to become critical thinkers and problem solvers who are inspired to lead the way in our rapidly changing world. They achieve that mission by supporting educators dedicated to unlocking creativity in the classroom and beyond. Kevin joined BitSpace in 2015, transitioning from a career in architectural design and project management. He wears multiple hats in-house, overseeing all the creative content and developing BitSpace's summer camp and online programming. During the shoulder seasons, Kevin leads BitSpace's furniture design, fabrication, and installation operations, leveraging his experience as an architect alongside their team's continuously evolving understanding of tactile learning environments. His technical versatility stems not only from his design background, but also his personal projects as a serial hobbyist and his exuberance for bicycle technology, maintenance, and of course, riding. In his spare time, Kevin designs and fabricates furniture, toys, and other crafts for friends and family. And last but certainly not least, we have Jen Owen. Jen is our creative director here at 3D Universe. We're very happy to have her on our team, but she's also a co-founder of the global Enable community of volunteers who create free 3D printed hands and arms for those in need. She's worked hard since 2013 to help bring Enable to schools and classrooms for STEM-based service learning projects and get kids excited about using their ideas and imaginations to change the world and help others. She's a mother of 3, and her youngest, a 15-year-old sophomore in high school, is currently participating in online distance learning at his school. So I'm very pleased to have these distinguished folks with us today for this discussion. There will be a recording available both in video as well as audio podcast form. To get the details, just visit our blog, 3duniverse.org. You'll see a graphic in the upper left for 3D Universe Untethered. Just click on that. It'll take you to a page with the recordings, as well as the list of upcoming episodes so that you can register for those. And with that, let's go ahead and get started. I think, talking about how to bring digital fabrication into a remote learning environment, perhaps we should just start with a little bit about the why. Why is it important to incorporate digital fabrication technologies? We're talking 3D printing, laser cutting, CNC, vacuum forming, etc. Why is it important to introduce students to these technologies? Maybe we could start with Jeff on that.
Okay, you have the opportunity to give kids more agency in their projects and their ideas than you might be able to do so in some other classes. So when I structure like non-pandemic learning stuff, when I structure the projects, I talk to the kids about the constraints of the project, but I try and make it so that the creativity part within those constraints is sort of limitless, so that the kids can make the projects about what it is that they're interested in. And I even tell them at the beginning of the year, I had one student, one of the most like fascinating projects I've seen. It was in the first year that I ever did anything with making, and first year I had laser cutters. She made this beautiful wooden box, laser cut, like a laser cut box, very intricate designs, an etched picture of her grandmother on the side, and then made it so that a tea light could go in it. And this girl was having a lot of trouble in her other classes. Like she was had a lot of demerits at the school, was having trouble, like struggling grade wise in other classes. But I could not get her out of the lab, which was great. I'd be there like late on a Friday night, and she wouldn't want to leave the lab. And it turned out she made that project for her mom, because her mom's mom, her grandmother, had just passed away, and it had Arabic prayers on it and all these other things. And so that was a way for her. She learned about laser cutting. She learned about 2D and 3D design. She learned these tools. She learned the workflow and the processes. But it was all within the context of something that was really important to her. And I've had other kids that are really into their car. Like a kid, like every single project that we did that year was about his car. It was 3D printing about his car, vinyl cut stickers for his car, like making adapter, like brackets for his car, or something to hold something in his car. It was like everything. But that's what was cool about it. I mean, like both of them learned the tools, learn how to take those tools and apply them to their own problems, which might be are often one-off problems, and then sort of learn by, like, the engagement is kind of built into it. So to kind of circle back to your question, there's no reason we have to get rid of that in this particular environment. Those, just because we don't have the kids in person doesn't mean that we can't create projects that allow them to solve their own problems or get into something that they're really into. Or and so what the twist, well, not the twist on it, I still do this anyway, but one thing I've been trying to do is think about how to do projects where everybody creates or builds a piece of something that goes together. So when we had talked before, we were talking about how the kids might not be able to come into the lab and 3D print their idea, let's say, or laser cut their idea, but they can. The design is the hard part, so they can do all the design, work on that stuff, get everything together, have to prep everything so that the files are ready, to go to a machine, and then I can click go for them for now. So if I click go and they 3D print something, I click go and they laser cut something, I can show them on the camera. That's the easy part. Clicking go is the easy part, right? And so I try and drill that into them a little bit so that they realize, yes, it's fun to press go and watch the thing be created, but the challenging part and the fun part and the creative part is all in the design. So I think it kind of lends itself better to the online learning environment than maybe I thought when it all first kind of hit the fan.
Yeah, that's great points. Kevin, any additional thoughts on that, the value of digital fabrication in learning?
Yeah, I mean, I think a lot of what Jeff is saying, it resonates super strongly with the kids that we had over summer. And, why use this technology instead of another medium of exploration of ideas? And, in some respects, it could be as one-dimensional as the novelty of having what we used to be considered untouchable technology. Just kind of, the doors are wide open, and it's like, you can use this incredible machine to do something compelling. What's that mean to you? And then kind of giving that the excitement of just being like, I have this idea. Does that sound like an okay idea? And us kind of being like, yeah, let's make it the best it can be, and then use a real tool to prototype it out. Right? We're not, at a certain point, cardstock gets old, and you want to level up your idea to something that, these car mods, right? I just imagine he's got some blinged out cup holder, some sort of double barreled, one for the hot coffee, one for the cold coffee cup holder thing. And yeah, you could make that out of paper and it would work exactly once. But now this student has an opportunity to use industrial manufacturing technology to make a more permanent and more realized visual of that idea. And sometimes that representation could last the life of the car, for instance. And that's just in one example. So it's like handing the keys to real fabrication techniques, not that prototyping with on paper isn't a real fabrication, but the next step, handing over the next step, the keys to these 3D printers and laser cutters, and letting the kids that are going to make the difference drive the bus. And that's super awesome to me. That's why we love using these machines. And what Jeff was saying about us just pushing go, at the end of the day, yeah, if a design is good and a design is compelling enough and you've had this relationship with the student, you know it's going to turn out the best it can, and you're just there to make sure you don't make spaghetti at the end of the day.
Right.
Yeah, Jen had a really cool idea before. I hope I'm not jumping the gun on bringing this up, but we were talking about the tools to open doors or push buttons, and like when I go into my lab still at the school, even though nobody else is there, and I have a little like a pocket knife that I can't see it because of the virtual screen, but I have it on me all the time, and just partial paranoia and just wanting to be safe. And every time I punch in or do anything, I'm always just kind of using that. And we were talking about, Jen mentioned like even a 3D printer project, a very introductory 3D modeling project of doing like Tinkercad or whatever tool you're going to use, and having kids design like there's so many opportunities to get creative with something like that. A hook to pull something, or carry a grocery bag, or push a button, or whatever it is. Hold a hand sanitizer bottle, or a little hook for your mask, or I mean, you put building something into your car, and you might hang your mask on, or whatever. In some ways, we have it easy. I think we have it easier than some other people do, because if we provide the tools and resources, the constraints, the understanding, the framework, scaffold this stuff for them, that all the things that have come out of my lab from kids have all been not my ideas. It's always their ideas, and so we kind of have the easy job in that sense. Like you set them up right, they'll knock it out of the park. You know?
Yeah,
That's for sure.
I think having been part of Enable for the last quite a while, I think some of my favorite stories from teachers are when we have kids who hate math, they hate science. They're to the point where, math literally makes them cry. And then suddenly they're introduced to 3D printing and the Enable project, where we make free 3D printed hands for recipients who were born without their fingers or who lost them. And you've got this kid who used to cry about math and wonder what am I going to use math for in my life. And then they learn that, you take measurements and you do this and that, and you have to design this. And suddenly they've used math or science or this new technology to create something that helps somebody else. And their little light goes off. And then you've got a kid who hated math, who's now showing up before school wanting to get into the lab to continue working on their design for something for somebody else. And you introduce this technology to them, even if they aren't there to push the button, they get to see their idea literally come to life in front of their faces. I mean, you could set up a webcam and show them, this design for this tool that you made for grandpa is currently printing on my printer at school. And when it's done, I'll get it to you and you can get it to grandpa. But I think, especially for K through 12, introducing this technology, whether it's 3D printing or laser cutting, you give that opportunity to find your future engineers, your future architects that didn't know that they were even interested in anything like that. You create a way for them to discover what kind of talents they have that they didn't realize they had. When we've got an Enable volunteer who started making and designing his own adaptions when he was like 4 or 5, and now he's teaching other kids how to do this. It's pretty incredible. There's
some options too. So a project we did, it's easy to Google. If you search my name, if you put Jeff Solin and Chicago flag, it comes up. But we basically took the Chicago flag. This is when we were in school, but there's definitely modifications you can do for something like this, even being remote. But we took the Chicago flag. I'm not sure where people are all coming to this call from, but I teach in Chicago public schools, and so Chicago is big on iconography and Chicago pride. The flag and the Chicago Star and these kinds of aspects of the city are Chicago residents get really into it. So we took the Chicago flag, chopped it up into 124, I think, like 5-inch or so tiles, full size, like 5 foot by 3 foot flag size. And then each kid made their tile. They had to stay within the vectors that I gave them of that kind of like chop, a piece of like a mosaic. And then and they had to stick with the basic color stuff. So if like a red star tip kind of came into one of the pieces, they had to hold that vector, keep that there, but they could extrude and make it red or laser cut acrylic or 3D print something or paint it red or whatever. But they had to stick within the general colors of it. And we just kind of rolled the dice to see how it would go, and it turned out really good. It's this collaborative art piece where you stand back and you see it, and it's a piece in and of itself. But then you can dive into 124 different spots and see every single different project that every kid made on it. Some of them are like not great. Some of them were seniors that were checked out, and one kid printed an Eiffel Tower, and I was like, "Why an Eiffel Tower?" And he's like, "Yeah, like I'm done. I'm graduating. I'm out of here." And then I had somebody else make these big white teeth. This girl made these big white teeth and then painted the gums pink. And she was asked if it was okay to paint it pink because that's not really white. And her tile was white. And I was like, I think it'll be fine. Let's just go with it. And finally, I was like, I got to ask you, what's the story with the teeth? Like, I'm all in and it looks great. And you did a great design, but why teeth? And she said, oh, it's a tribute to Sue, the dinosaur at the Field Museum. And I was like, that is awesome. And so now there's like a big, grill up in the corner. And that's been at the Museum of Science and Industry for a few years now on display. And the kids get to go there and visit and see it and be proud of it. And they're real proud of themselves. They see their name on the wall, made sure every kid got credit. And we did another project recently. I haven't released it yet or shown anybody, but it's basically taking all the 77 community areas of Chicago and did this whole thing off of No Small Plans, a book through the Chicago Architecture Foundation. And each kid did a representation of their of not theirs, but somebody else's community area in Chicago to learn about it and what would make them proud. And now we have this like 8-foot giant city of Chicago with all these different pieces that the kids did. I'm writing a piece about it and I'll publish it. I haven't done that yet, but these are all opportunities. You can get as simple or as big as you want by having kids work on a part of something bigger, and then we can 3D print it or laser cut it or whatever we got to do, and then put it together on site, and they could be part of a larger project without with the design on them, but the fabrication part of pressing go on us.
Yeah, those are two amazing examples of that. The answering why, right? Like in a lot of respects, these tools beg to be collaboration tools. Whether it's using the technology to get people to work together on something to help someone in need, or to work together on a bigger scale project to express themselves and to kind of share something that might be important to them, or, the Eiffel Tower. But still, like, that experience, that they're never going to forget that. And, they might look back and think like, well, that was an amazing opportunity. The next time that comes up, I'll do something different. And it'll be like shooting fish in a barrel because I already know how to do all of these steps. And in some respects, you might be a couple of years ahead of the game. So it's kind of shoehorning some really good skill sets and collaboration skills at, high school, middle school age, when, some of the stuff, I would say, even in like undergraduate classes, you don't get enough of. So it's pretty cool.
I like the idea of giving kids a problem to solve, and then letting them like with the Enable community and the Maker community, You know, say I broke the knob on my car heater. You can go and I could design it myself, and then I can upload it to Thingiverse, and then some poor soul in, you know, some Minnesota in the middle of winter broke theirs too, and they don't have access to it. They can download it, modify it if they need to. Same kind of thing with the kids doing stuff. Like right now, we were, you know, when we were talking, there's a big push for PPE, for masks and ear savers and face shields. But there's also, you know, things that as we're in this pandemic, you know, 6-7 months now, we're finding things that would be helpful. You know, I just flew to Florida to watch my sister's house, and it was the first time flying, and you know, I really wanted something to put my hand sanitizer in. I had my little travel pack of, you know, wipes and stuff, and then you're, you know, what do you do with your mask? What stuff like that. So I think it would be really cool to invite the kids to design for the pandemic. You know, PPE isn't just, you know, face shields and stuff. It's protecting ourselves from this virus. You know, maybe you can design a hook for the rearview mirror. So, or, you know, my center console looks like a disaster right now. I've got 4 or 5 different masks in there, a couple of different kinds of hand sanitizer. You know, even just coming up with like a little organizer for cars, for PPE and, you know, things like that. And then uploading it to Thingiverse or GitHub or whatever, where it's a collaborative thing. And they can go there and they can see, I woke up this morning and 25 people downloaded my design, something that I made, and it's helping other people. And it doesn't have to be, you know, a 3D printed hand or whatever. Like, there are people who would just really like to have something 3D printed or even laser cut, and they don't have the skills to actually design it. I have a laser cutter at home, and I'm really good with vectors, but I'm still trying to figure out that caliper thing. So it's easier for me to just go on Etsy and order something that I want to laser cut, where, you know, with you got a group of kids, get 30 kids, give them the, you know, how do you solve this problem, put it on this website, and then other people can collaborate and change it and modify it and make it better. I think that's a really cool way for kids to get rewarded and to see their work used.
So lots of great points here. Clearly, there's a lot of value in bringing digital fabrication to these students. So let's talk a little bit more about the how side of this, because again, there's some unique challenges with this remote learning environment. Maybe a good place to start is talking a little bit about the workflow. We had some discussions previously about this in our group here, and the notes I captured were going from kind of brainstorming to sketching to maybe some 2D or 3D design on the computer, then maybe doing some physical prototyping, just using common materials that might be available, and then going to the digital fabrication where you're doing 3D printing or laser cutting or what have you. And then of course, iteration, because, you know, usually the first one isn't going to be the winner. And that's part of the process. So let's talk a little bit maybe about how, you know, which parts of that process lend themselves well to remote learning. Because as Jeff, you know, wisely pointed out, you know, pushing the button on the printer is no big deal. That's actually the smallest part of the process. It's more about the design part of this. So maybe we can talk a bit about the value of bringing that digital fabrication workflow, but focusing more on the lead up portions of that workflow, the design, brainstorming, and all of that. Do you guys have any thoughts on that? And I'll just open this one up to anybody who cares to comment.
So you're talking about like basically all the work that comes before push and go.
Exactly.
Yeah. Well, I think it kind of all comes from, you know, a design prompt or a prompt that is resonating with a school or a class or a student. And, you know, personal protection equipment is a pretty relevant situation right now. that you can, I think, as a industrial design challenge, if you will, is a novel way to get people to think about us like occupying space together in a way that we haven't had to consider before. You know, and I think the challenge is just kind of figuring out a way to wrap that up into what you'd like to educate on and what you'd like to learn yourself about, what you'd like the kids to learn about, and then use technology as kind of the medium to kind of like, you know, put the final stamp of like memorable, like solid learning moment at the end of a project. You know, for instance, like, you know, if I want to make a, I don't know, retractable, like Wolverine style shopping cart pushing claw, like I need to learn, I could just do it, right? That's one option and it might turn out a certain way, but what a superb opportunity to talk about the anatomy of the hand. What an excellent way to talk about, you know, leverage ratios and the finite strength of different materials. What a great way to talk about whether or not that's even a good idea to have a Wolverine claw that can come out of your hand, right? So what, you know, it's kind of asking yourself, like, what is the topic at hand and how, like, what methods or what kind of like learning experiences do I want to engage with in the realm of that topic? And you can almost roll dice and, you know, say, you know, I want to talk about physics and, you know, well, awesome. Like we need to develop a door pusher that has the, you know, the maximum strength has to be the minimum allowable push on a public door, which is, I think, like 5 pounds per inch or something like that. So like, you know, you can actually start to do some research and talk about, you know, how much applied force you need to operate a door and then develop a product or an idea that does that action, that isn't overbuilt, isn't underbuilt. So you can establish design constraints, like, you know, it has to weigh a certain amount so that you don't just have, you know, somebody come up with like a 3D printed 2x4 and, you know, it's like, well, it works. And yeah, it's just an outstanding opportunity to talk about executing an idea by proving it out on paper, and then even doing, you know, some finite element analysis in something like Autodesk Fusion, which is something we like to use around here, to show that, like, if I apply 10 pounds of force directly into this object, it will or will not exceed like the bending capacity of whatever material I decide to make my thing out of. And it's probably going to be, you know, PLA or plywood or MDF or something laser cut. But yeah, I mean, it's like a choose your own adventure book. And I think in a lot of respects, it's, you know, the how to get started is almost so easy that can be overwhelming. And so I guess maybe, so I can quit the ramble, my recommendation would be to pick something that you're passionate about also, because your personal buy-in has to really, I mean, unless you really love just doing random projects all the time, having like a personal stake in an outcome can really help kind of push the envelope. And the kids will obviously sense it too. And I'm sure at this point, that's like preaching to the choir. I know so many teachers that, you know, they teach with, you know, the glint in their eye every day, and their students love them for it. So I guess that's all I have to say about that.
That's a great point, Kevin. And it's actually a really good lead into something that I wanted to bring into the discussion here. I want to sort of bring in a couple of our attendees. We've got 2 questions here that are actually very related and relevant to this topic of, you know, how do we do this? How do we bring this digital fabrication into this remote learning environment? So one of these questions was, can you please talk about just the nuts and bolts of how to make this happen in a remote setting? And the other question that came in, which I think is related, is, Jeff, would love to know how you facilitate student design if students are issued Chromebooks. You're using Tinkercad for 3D printing, other tools. What do you use for laser cutting? Are you using Inkscape or vector extension or what? So let's maybe take this as an opportunity to just talk about that, you know, maybe walk us through, Jeff, the process of what do you actually go through to bring, you know, the whole workflow of a digital fabrication project in remote learning, and kind of talk us through the process, the tools, and everything.
Okay. Part of it, I'm going to tell you what I have in mind, but I don't know how to do it because I haven't done it yet. So like, I've got ideas and I'm going to tell you what I think might work. But I have not taught it's I don't know how many teachers are on the call, but it's strangely exhausting and a little terrifying and difficult for both for teachers and learners. And Jen, like you, I heard you had a 15-year-old. I have a senior and a freshman that both go to the school that I teach at. Both go to Lane Tech. So I have a almost 18-year-old and a 14-year-old. So I'm trying to do the parenting side too, right here, while also teaching on my classes. But so I don't know what's going to work or not yet. But what we're doing to address some of those things that you said, we have an idea to, and I don't want to spin off too much on this, but we're looking at doing what we're calling an engagement box, which is we would deliver a kit to kids that has a particle photon, a little microcontroller, a few buttons, probably a slider, maybe some default sensors like a temperature and humidity. Those are really easy to add, the light sensor, temperature and humidity sensor. And then maybe not, like a little OLED screen that could give some information back. And the idea is we're just going to use MakerCase to give them again, talking about constraints, trying to do constraints, but also give them opportunities for creativity. So maybe say, all right, you've got a 1 foot by 1 foot square of material. You could choose acrylic, or like there's constraints are you could probably choose 1/8 inch acrylic or 1/8 inch Baltic birch wood, and for whatever you'd like to use. And then you have that fixed amount of material. Use something like MakerCase to make a box, or I'll give you a default box just to work with if you want to do that. Learning on the digital tools, which I'll talk about in a second, using, like, you got to cut a hole. We need a hole that's 3/4 of an inch so that button can go into it. So we need 4 holes. So put 4 holes in there. Here's how you do rastering and maybe image tracing. And then you can add whatever neat things you want to that box, and then get the plans to us. I'll run the jobs, and then we're going to deliver. We would deliver that basically as a kit. So we'd give you the buttons, we'd give you everything. We'd give you the code. At this point, in this particular class, we would just give you the code so you don't have to know programming. You would dump that firmware onto the Photon. And as long as you wire it up, which we'll talk about, but just that should be pretty simple. And we've done this with other projects in school before. Then ideally we would have a way for those boxes to send information to us, to broadcast information to each other, and then sort of we will see what opportunities open up with that. And then we've got all kinds of ideas, from, like, the idea was to make an engagement box so that kids, especially even kids that don't have video on, have a way of engaging, and it's kind of fun, and they're learning to build their own thing, and they can customize it and make it their own, but they have this sort of button box to give feedback, like similar to something like Pear Deck or Socrative, or like a million other tools like that teachers have right now. So that's one project idea. There's lots of stuff around the house you can use for prototyping, from cereal boxes to tape to paper, sticky notes, pencils, toothpicks, spaghetti. Like, we could find ways to have kids do some lo-fi prototyping. I think that part would be pretty easy. And we can also have a pickup station at the school. They want to come by and pick up some of those things. They don't have markers at home. They don't have rulers. We can get that stuff to them. That's low cost enough that we can pull it off. Even in a public school. So to go to your tools question, in our environment, we ended up writing a grant and getting Adobe CC licenses. And we've had a lot of trouble with one of the hard things. I'm a computer science teacher, so I teach some more I teach making, and I tell the kids the maker class is a computer science class at our school because I'm a computer scientist. I'm the one that did it, but it's like this middle of a giant Venn diagram of engineering and art and computer science and architecture and math and everything else, right? That's what's so beautiful about it. So, but it happens to be a computer science class, and I teach some other more standard computer science courses, like I teach a digital logic and hardware design course. And it's been really difficult because I've got 150 kids under my belt. I've got people on Macs, people on PCs, some kids on Linux, and a whole lot of Chromebooks. And the Chromebooks are pretty capped off on functionality a lot by Chicago Public Schools. If it's given by Chicago Public Schools, then there's a lot of things you can't install on it. So we have through this grant, we have the luxury of using CC, Adobe CC, but which is limited to Macs and PCs and no Chromebooks. Now, even if you switch to something like Inkscape, which is totally fine and works great, if you're doing Inkscape, you still need a Mac or a PC. You can't run Inkscape on a Chromebook. So what I did was got some funds together, and we're using. I can't tell you how well this is going to work yet because I'm literally in like day 2 of it. But using Paperspace, and Paperspace is a VM company. So what I did was I set each of these kids up that only have Chromebook access to hook them up with a Paperspace account, and then they basically log into a VM, a virtual machine of Windows 10 machine in a tab, and then they full screen it, and they're on a Windows computer at that point. And I can spin up and reboot those computers, reinstall whatever I want, and then you can manage it all remotely. So it ends up it's $5 a month for a license for a computer, and then the cheapest is 7 cents an hour up, and then we're doing like the 10 cents an hour plan, which gives them 8 gigs of RAM. So they have a full Windows 10 license. They can install stuff. We can install Adobe CC on it. We can install Inkscape on it wherever we want, and then they're able to use that in their Chromebook. And then and there's some other challenges to go with that, but so far I think it's going to work out okay. And then and the number of machines we need is the max number of kids in one particular class that only have a Chromebook to work on, right? So then the kids share those machines across periods like they would for a machine in the lab. And then just one more thing is Tinkercad. Well, we use Tinkercad usually to introduce 3D modeling. It's just really awesome and a good tool, and that can work on a Chromebook. And then I know Kevin mentioned Fusion 360, and one of the challenges that we have is kids being able to install something on a computer, and also on a Chromebook you can't use Fusion because it needs to have an install. So we're kind of big into Onshape. Onshape is a full enterprise level 3D CAD program. It's not as good at CAM that Fusion is, but at this stage of it, CAD is phenomenal. There's free mobile device apps like on an iPad and on Android devices and iOS devices. You don't need any install at all. It's fully cloud-based, so you do need a stable internet connection. And Onshape provides the entire, they just changed this. They do the full-on, multi-$1,000 enterprise version completely for free for students and educators. And they have curriculum to go along with it, which is really well done. A great staff team. The team is really good there. They'll set you up with your own subdomain on their servers. So we have lanetech.onshape.com. It's all free. They have you sign a paper for a $3,000 grant. It took 5 seconds, and then they give it to you for free. So we're going to dive more into Onshape this year than I normally do because of the remote aspect of it. And I'm going to start using. This is circling back to the prototyping thing, and I'll stop talking. I'm sorry I'm talking so long. But we'll circle back and use. I want to try using more 3D modeling to do more prototyping, more lo-fi prototyping. So maybe you're not going to 3D model that thing to just 3D print it, but you're 3D modeling it to get this concept of whatever it is into a 3D model. And then maybe you end up 3D printing part of it, or maybe you end up laser cutting part of it, or milling part of it, or maybe part of it's a sticker or whatever, but just a way to use it as a free, very functional prototyping tool. So that's, hopefully that addressed some of that stuff. That's what we're trying.
Yeah, that's really helpful. So I heard quite a few important points in there, but just to kind of highlight on the tool side of things, it sounds like for CAD, when we're in an environment that needs cloud-based tools, we've got Tinkercad and we've got Onshape as 2 really good options. And when we go into 2D design, you mentioned Inkscape needs an install. Have you come across or used any of the 2D design vector tools that are browser-based?
Yeah, Vector is the only one.
Okay.
Yeah, VECTR, but honestly, I have very little experience with it because we've been lucky to be able to use Illustrator. So all my curriculum and everything I've done over the past number of years has been using Illustrator because we have a lab set of computers in my lab, and so the kids they're not theirs, but they come in and they log into their account, and then they have that. If they have a machine at home with CC, they can log into CC on their home computer as well because you get multiple installs of it. So, but I mean, Inkscape could be swapped for that, no problem. And Vector, yeah, so Vector, and then we use Silhouette. Silhouette Studio we use for our first intro to design is usually on the Silhouette cameos. So they make stickers or they make iron-ons like for a t-shirt, or they make whatever they want using that tool. And that also has to be on Mac or PC, and it's free. But so this is where that VM is going to come into play again.
Yeah.
So if we couldn't figure out the VM, our plan was to switch to Vector, but I have very little experience with it. It looks pretty capable for doing an introduction to 2D design and what vectors are and what rastering is and why it's important and all that kind of stuff. But I don't have a lot of experience with it.
Yeah. Okay. And I think I just got another question in from the audience, and I think we already covered some of this. The question is, would you recommend using Tinkercad for elementary school, pre-K through 8th grade? Yep. What software, again, get thumbs up there from Jeff. What software would you suggest for 2D laser cutting? So you mentioned Vector. She says our CPS students have CPS Chromebooks. So this is
they're on CPS, yeah. For laser cutting, try. It can also depend on what machine you have. If you have like a Glowforge, Glowforge has some design tools built into it right now, and they're offering for free. So you can do that in the cloud also. It all depends on the machine you're using. But if you want to use generic vector design tools, I would say Vector on a Chromebook, Vector, VECTR.com. Yeah.
There's another one that I haven't used this on a Chromebook, but Canva, CANVA, is another cloud-based vector tool that I'm guessing would work on a Chromebook. So it's cloud, it's browser-based.
By the way, I should throw the caveat out there. Whoever is on this call from CPS, I didn't say anything about using Paperspace, and I'm not using that, and I'm not using it with the students. And I'm very much on the forgiveness versus permission path in my life. So please don't get. I think it's going to work out well, but it'll only work out well until CPS finds out about it.
Fair enough.
Well, I heard you say hypothetically. Yeah.
Yes, hypothetically.
Distinctly. Yeah.
In an ideal world, that's what we would do.
Yeah,
that teacher mentioned that she just got a Dremel Digilab LC40. So that's one I'm familiar with. Great laser cutter, but their software does not have the design capability built in where you can actually do the vector design as part of the software. So you would have to look to some of those other tools that Jeff mentioned to do the design and then bring that into the Dremel software. So,
and I'm using the Flux BMO, and in their Beam Studio, I have the access to the pen tool and shapes and things, so I can design right there and on my, and actually I was using my Chromebook. So
There's another little fun prototyping or initial stage project for the teachers on the call. Every year I do this project. It's one of the first things I do, and I call it the mystery object project. And I take a device, a thing. I usually use a plastic bender because it's so simple, and it is so confusing because like they don't know what it is because they've never thought about bending plastic. But it's just like a little table with a hot bar in the middle and one switch that turns it on, and a caution hot sign. But it throws everybody off. They're like, can't figure out what it is. So I pick an object they don't know, and then I put it up in a room, like a loft in the lab, and I break kids up into groups, and one person from each group is like the seer, and the seer can go up there as many times as they want and look at it, but they got to come down and describe it to the drawers, and the rest of the group has to draw it, and the seer has to describe what they saw and guide the other people in how to make it a 3-dimensional drawing and change the proportions and all this stuff. So I tried that remotely, which was tough, but it worked. So I just had a breakout room. We have to do like fake breakout rooms in CPS because we have Google Meet, and it's what Zoom would be if it was the 1920s. But so I had them go to like a separate breakout room with me only, and then they would come in there, and I held the object up and showed it and let them take pictures and screenshots. And then they went to their breakout groups and had the kids showing the drawings and then doing that kind of stuff. And so we do that as an introduction to sketching on isometric paper. And there's a couple good sites that you can just print your own isometric paper, or try and get, if you can, buy the kids. Normally we buy it for them in the lab, but buy them isometric notebooks so they can learn to draw in that kind of way. It's very hard to do for some people, and it's a good practice thing to start prototyping with. Just sketching your idea in 3 dimensions is hard.
Absolutely. Great. So, all right, we've had a lot of good information already. We've talked about the why of digital fabrication. We've talked a lot about the how and some tools that you can use. Let's shift gears now and get into some project inspiration. I want to give a lot of ideas to the teachers joining us today, just to kind of get the creative juices flowing, give them some ideas of where they can start. Obviously, these teachers are all, creative, and the students are creative. They can come up with their own twists on these. But let's give them some seeds to start with. And I want to, again, invite the audience to join us in this. Use the Q&A panel, share your ideas. If you've done projects already that have incorporated digital fabrication, share those with us so that we can share those with the rest of the group here as well. So any of you guys like to share specific ideas that you have for projects that would be good to kind of challenge students to get them into this designing and creative thinking mode?
Well, I recently did a blog post on laser cut stop motion animations. And I thought, as I was watching and got sucked into the rabbit hole and couldn't stop watching all these, whether it was made out of paper or laser cut wood or this or that, but I thought it would be a really cool project to give, create a story with the students, let them all collaborate and come up with a story, or maybe the teacher reads a story and then each student is assigned a character or a background piece, or the sky movement or the water, and then those kids are each tasked with their part of the final product, where you've got one kid who's in charge of making the little creature walk across the screen, raise his hands, throw something in the air. You've got somebody making the birds go, and
that
then
sounds awesome.
Everybody puts it all together, and the teacher at the end, you have a viewing party and everybody gets to see how their part worked, and just kind of make, even a 10-second stop motion animation as a class project, where the teacher can laser cut or 3D print, or the students could even I don't know, but I just think that would be a really cool project.
I love the collaborative aspect of that, Jen, and to build on that, in one of our previous discussions, we had talked a little bit about this idea of doing something similar, where the class might read a book together and then collaboratively come up with a diorama, like we used to build in little cigar boxes and stuff. Well, you could have the students 3D design components, where each one of them gets a little component to design of this diorama. Those get 3D printed and assembled and can then be shared. So I think there's different aspects, different angles you could take on that idea of collaborative design of each of the students taking on a different part, and and then kind of having it come together at the end.
Mm-hmm.
And if you bring in some electronics into it, I mentioned the particle photon a little bit, and one of the reasons we love that is because it's you can use it on a Chromebook. The IDE is all web based, and so you can dump new firmware to it through the cloud. But there's also you can do this on a Chromebook too. So there's also microbits, and microbits are cheap and awesome, and you can do some really cool stuff with those. And this might be a little wonky, but it's still fun. My buddy, I stole this. This is not my idea. This is my friend's idea at Lane, Dan Law. But he did a Rube Goldberg type machine, but the students pass to one another through messages over the web, basically. So each kid got really simple components. They got a motor and a limit switch and a marble, I think. And then they just, with cardboard and other stuff, the motor would let the ball go or knock something, I think. And then the ball would come down, and when it hits the limit switch, the photon would send a message over the web to the next kid. So this was all in the same room, but they had these stations, and he ran around and filmed it with his camera of the Rube Goldberg it's kind of a Rube Goldberg machine. It's not really, but kind of is, but going around the room. And so you might be able to have just even a simpler thing of messaging, like using microbits to send messages from, no, you can't use it over the web, but those is easy. But you could send like messaging with like something like a photon, where my thing is done and it says, okay, like Jeremy, your thing is up and your thing is listening, and grabs that message and does something. So you can use some with really like limited, pretty introductory level electronic stuff. You can do some fun stuff with that. And I still think of that as making.
Yeah, that sounds like a lot of fun. All right, other ideas.
I think like project hacks are always fun. I think if you need something that is easy to provide or easy to find, I again, like, part of the, knowing it's a good idea is that you see it in several places and it keeps getting better. But I was just on, a website from Brigham Young University called about compliant mechanisms, which was a new vocabulary term this year for me. And it's wonderful. Basically, it's the idea of making a simple machine that doesn't have any hinged parts, right? So like making a pair of pliers via the 3D printer that can grasp something just through inflection points. And some of the most popular examples were all like tensioning devices for like Lego Technic projects. And that's, I think, a really great way where you might be able to send a couple Lego bricks, to each kid in a class, assuming they don't have them on their own. And then, maybe the idea, I'd probably get in a lot of trouble with parents for saying this, but like, the competition is to see who can fling the Lego the furthest, right? No punishment greater than stepping on a Lego, but
yeah,
how do you make a mechanism, a compliant mechanism that is Lego compatible, for instance, that can perform an action. So you're getting super precise with measurement and a little bit of fungineering involved. But then, the teacher in a controlled environment, we have all of these go buttons back here. We print the whole batch of them. Part of it, you make sure like their initials are on it. And then maybe that's actually the Friday at the end of the quarter is the teacher tests them all to find out which person made the best Lego flinger. But something where find something that's ubiquitous and try to make it more novel or improve upon it. And Lego hacking is brilliant. There's so much incredible. It's like that and Nerf. You could write a book on the stuff that's out there for people that are just modding these toys and these activity sets.
And that's neat, because it not only gets into the design challenge of coming up with the correct design for that, but it gets into materials engineering and the physical properties of different materials and which one's going to give you the flex and the strength that you need and that sort of thing. So there's a lot of cool aspects to that. Another idea that I've been thinking about for a while that I'll share, though I'm not a teacher, but I thought that a really cool project for 3D printing would be taking the old bridge building contest and bringing that into the digital fabrication realm, where you challenge students to design a bridge where, these are going to have to be smaller bridges given the limitations of most 3D printer, sizes, but you challenge them to design a bridge to span a certain amount of area, a certain amount of distance. And here's the key, is that you can have them not only do the 3D design and the modeling of this bridge, but actually go into the slicing side for the 3D printing. Because a lot of the 3D printing platforms out there offer cloud-based slicing platforms. So if you have, MakerBot or Dremel or Raise 3D, a lot of these platforms have cloud-based slicing where the students can go in and play with the slicing settings. When you do the slicing, you play with, how thick do you want the walls, how much infill do you want, et cetera. And after you do the slicing, it'll tell you exactly how many grams of material are going to be used. So you can limit the students to saying, you need to design something that uses no more than, 40 grams of PLA. And so that limits them to a certain amount of material. So they have to balance their infill amount with the actual structural design and how thick it is, et cetera. So it gets them into not only the design challenges, but really teaches them a lot about those slicing concepts leading up to the pushing of the button on the 3D printer.
Yeah.
I like that a lot.
Sorry, go ahead.
I was just saying that sounds really cool. That sounds good.
I said the same thing at the same time.
Yeah.
I think it would also be cool to have the students designing for their own learning spaces. I believe I saw somebody had designed, because they couldn't figure out how to view a document, they designed a laser cut thing with a mirror on the bottom so it could project things back to the teacher. I know, Jeremy, you designed something for your laptop that would hold your phone, I believe.
My iPad, actually, little stand that clips onto the side of the MacBook to hold the iPad next to the MacBook screen. Yeah.
I just like the idea of, these students are in their own homes. They have their own spaces. Some of them have to sit at the kitchen table. Some of them have their own little cubby. Some families have gone all out and redesigned a part of the garage. And then you've got the kid who's just, sitting on their bed with the laptop, and they have the pile of stuff that they need to do, their notepads, whatever. But if you, design something for your own space, do you need something to hold your pens? Are you in kindergarten? Do you have stickers you need to, what kind of things do you need in your own space to make this virtual learning easier?
There is this might be too much of a spinoff, but when you said that, it reminded me of the very first year that I built my lab. One of the projects I did with the kid, I had no idea what I was doing. I mean, pretty much, I don't know. Sometimes I just feel like I don't now, but I really didn't know what I was doing back then. And so I was like, all right, your project is a final project was you got to make something for the space, something that either aesthetically or functionally enhances the lab, because the lab needed that kind of stuff. And some really cool projects came out of that, but it made me think of designing for a specific space, and it made me think of designing one-off things, which is one of the beauties of digital fabrication. Is we might not need 1 million of them. We might just need one of them, and it might be the one thing for you, and nobody else cares about it. But that's kind of the beauty of it. And one kid made we didn't have a flag in the room, in every classroom has an American flag, and there generally does, and we didn't have a flag, so he laser cut out of translucent red and translucent white acrylic these little pieces this big, rectangles with holes in them, and then used fishing wire, and they're stripes, and then embedded the white stars and the blue, and it turned out super cool, and it hangs in the window so the light shines through it. And then I had to make let me think. Oh, for that one, this is an next year up. They had to find a client in the building. The client could be a teacher, it could be a department, it could be maintenance staff, the lunchroom people, it could be administration, the whole student body, anything. And one of the students said, "Can you be my client?" And I said, "Yeah, I'll do it for one group." So they, I taught them how to interview people, find out what the problems are. So this is something where they could do an assessment in their own space at home. What are things that you notice about your daily experience? You go and you sit down for class. What are the pain points? What are things that are not working well, or what could be improved? And so they interviewed me, and I said, I forget, I have tea every morning, and I forget my tea thing all the time, and I leave my coat over here, and I get in the car, and I'm like, I forgot my tea. So anyway, they made me a coat hook tea holder that goes next to the door, and I might be the only person in the world that needs a Kodak tea holder, but it solved a problem for me, and it was about that space, about that environment, and so the kids just needed the prompt. So I think to spin off of your idea, Jen, I think it's great. Every one of those. This is what's so great about making. We don't have to be like, design this for your space. It can be like, in your space, what are the needs? Because everybody's needs are different. And what can we come up with that's a project and challenging and fun for you to solve a problem or enhance something for you in your environment that you're in every day? I think that's a really good prompt. I'm gonna steal all of your ideas. That's
exquisite, for real. Like,
I think
just getting. Oh, go ahead, Jen. I'm sorry.
Oh, sorry. I think it would be also really cool to not just have them, designing for their own space, but we're all stuck in our houses. You could make it a project where you FaceTime with grandma and you ask grandma what she needs in her house. What could we design for you, grandma, that would make things better for you? And then they work with that person. They, show them designs. They, that person decides, I like this one better. Maybe you could make it bigger. Giving them the opportunity to go back and forth and learn from their iterations. And, maybe it didn't work the first time. Maybe grandma wanted maybe her phone was bigger than I thought. That kind of thing. And then at the end of the project, the teacher pushes go, and then they get to, have that, pick it up or delivered to them, and then they can give it to grandma. And then grandma can show them from her camera that you designed this thing for me, and it is helping me in my situation. And they, again, get to design for the greater good.
Yeah, I love those kinds of I love projects. That's what's so cool about this stuff, is just being able to design things, not only for yourself, but just designing things to be able to help other people. And so that was the whole inspiration behind that project. It was a few years ago, but just like finding a client in the building. Kids made all kinds of stuff, and people have different needs. And some people needed certain things in their classrooms. Teachers did. Some kids made like a map of the whole school to put up. That was for the whole school. Like just lots of ways to do things that can make somebody else's experiences better. I like it. Those are really cool. Jen, I don't know if you heard me before, but I'm totally stealing like all of your ideas.
That's the whole idea.
And I'm going to tell my students that they were all my ideas. I'm just
kidding.
All right. I'm just kidding.
We want people to steal these ideas. Run with it.
Yeah,
so we're actually just about out of time here, so we're going to start to wrap up. But I hope this has been useful. We've had so many great ideas here, and I hope we have inspired some folks to take up some of these projects. And let's see, I'm just going to check to see if we have anything in the.
I'll explain to you this in the background. By the way, I made this my virtual background because this was 3D printed. That's part of the building of the school, Lane Tech, and these trees, and that a kid designed it completely from scratch. That was all in Tinkercad, and that's part of the red star from that Chicago flag. And it was this is the Chicago flag, so you can see it. Wait, let me move. Oh, wait.
Yeah.
Right there.
Nice.
And that was like all these different things being put together. So the mosaic kind of ideas where everybody contributes to one larger piece of something, whatever you end up doing with that, those can be really fun for kids because everybody gets to look at that and know that they had a part in it. And so it's like that worked out really well. I don't know how I'm going to do that. I mean, I like Jen's idea of the stop motion thing. That's or the diorama that Jeremy mentioned. Like these are collaborative projects where they all contribute to one greater project, and I really love those ideas. And I mean, anytime I've done something like that, it's been a fun experience, and I think fun for the students too.
Jen, I saw you pointing at something. Did I miss something?
Yeah, Kevin has something he's got to say.
Oh, please.
You?
Yeah, you were gonna say something.
Oh yeah, okay. So, but I could go for like a half an hour on this, but I'll keep it concise. all the talk about designing objects for space, it'd be a disservice to ourselves to not talk about designing us in space, and reimagining the classroom. It's a project we had a lot of fun and success with in the spring, was getting kids up out of their desk and measuring their room, and then building a floor plan out, teaching all of the basic functionality of 3D modeling, but to represent themselves in the space they currently occupy to learn. And then the second half of the course was improving that environment in some way that's within the realm of infinite possibilities, right? So if you want a levitating desk, well, now is your opportunity. And then bringing that down into practical 3D modeling techniques, and then ultimately practical fabrication techniques.
Oh yeah, now gravity is gone. You could be like, I could put a whole nother desk above my head.
Yeah. I mean, you're currently working in the upside down right now. I heard that about reality.
Yeah, that's a cool idea. Using having kids sort of use the 3D modeling tools to map out their own environment, try and build. I mean, you can do it. It can be as simple and like hacked as you want. Like a couch, you can build it like with simple design ideas. It doesn't have to look like super rounded off nice couch, but you could do a couch looking object in both Tinkercad or Onshape or Fusion.
Yeah, that's a really neat idea. And how
if you ever wanted a couch that looked like Appa, from Avatar, like you could just go ahead and give that a shot instead. Like, and the next thing you know, that thing will show up on ThinkGeek. Ooh, poor ThinkGeek. Aren't they?
Yeah.
I don't think ThinkGeek's around anymore. But.
And how cool would it be if students could sort of redesign their classroom, and then, when they eventually are able to come back to the classroom from remote learning, they actually find some of these ideas implemented.
Yeah, implement it.
That's exactly right. That's that big moment where like all of the ideas start to be shown, like the Chicago flag, like the district mapping, projects like even just reimagining what your playground could look like once playgrounds are back to being fully open, and more importantly, more accessible than ever, hopefully, to students of all ages and ability levels. There's so much you can do, and like 3D modeling and two-dimensional design for laser cutting specifically start to give you those really tactile results that can prove to yourself almost that your idea can be built, or it can be assembled, or it works to scale with this other thing that you're working with, a design constraint of some kind. Talk about, and like I have a couple of notes I was taking. I hope it doesn't look weird on camera, but I was sitting here writing down some of the ideas we had just because I wanted.
I was going to ask if we can.
We're going to be sharing notes, so that's a good lead in to kind of wrapping up here, because I know I'm feeling inspired. I hope others that have joined are. We wanted to share a lot of ideas, which I think we've done, and so Jen is going to be helping us to put together a blog post follow-up for this, and in that blog post, we're going to share all the links to the tools we've talked about. We even have some slide decks that were shared by some of the participants. Some great websites that'll help you in these projects. So all that information is going to go into our blog post. So please follow up and visit 3duniverse.org to find that blog post in the next several days. And we'll also be sharing the recording of this both in video format as well as a podcast. So if you want to share this or revisit some of these ideas, you'll have that available in the very near future. So I want to give a big thanks to our speakers today, Jeff, Kevin, and Jen. Great job. Glad to have you guys with us. And thanks to all of our attendees for joining. I wish you all well. And
thank you very much.
Yeah, it was our pleasure. Thanks so much for having us.
Yeah, thank you very much.
I'd like to invite everybody to join us for our upcoming episodes as well. Next episode, we will be focusing on the Enable community and 3D printed prosthetics, and how we have incorporated that project into over 2,000 schools around the world. We also will be talking to a maker in Portland, Shashi, who for episode 4, who started a makerspace there and has delivered with his community over 66,000 pieces of PPE. And now they are using their maker community to create 3D printed brains, so that the students who would normally get to do that for their neuroscience with actual brains can still do their learning. So we've got some really cool episodes coming up, and we'd really love to see you guys join us.
Yeah, excellent. So again, go to 3duniverse.org. In the upper left, you'll see a graphic for 3D Universe Untethered. Click on that and it'll take you to the page where we have the listing of their upcoming episodes as well as recordings from previous episodes. Thanks everyone for joining us. Stay safe. Bye-bye.
Thanks. Bye-bye.
Bye. Thanks.